Hello YouTube, it's DasGregor, and thank you for tuning in to what hopefully will be a little bit of insight on the Linux kernel and Gentoo. This isn't going to be too much of an in-depth review because I hopefully will be going a little bit more into it when we look at Gentoo installations when we get to the kernel module. But I just wanted to give a couple quick tips and tricks that I have learned over the years. One of the biggest things when building your kernel is making sure that it has all of your hardware ready and either built into the kernel or built as a module. So one thing I like to do sometimes is take a larger Linux distribution that just works and you know everything is running proper, boot into it, and then either look at the ls mod, if I can get into my area here, ls mod, and you can see I've got very little running. I like to build everything into the kernel and then not put anything else out there. So VBox is for VirtualBox drivers. The SDHCI, PCI, and HDCI are, and MMC of course underscore core are all used for the micro SD card reader that's built into it. And then R8169 is the Ethernet adapter, and then core temp of course just to check what the temperature is. But the other thing is if you've used a big boot disk that loads everything as modules, they're going to show you everything that's there, and it's going to be a huge long list. If you log in, for instance, with the minimal Gentoo, you're going to see everything listed as modules, and that's going to become very handy in the near future. You want to make sure you write those sort of things down. Another big thing is LSPCI is going to give you a list of all of your PCI hardware. LSUSB is going to give you a list of any USB-based hardware, like the 4 gig flash drive here. Also, the video webcam and all that should be in here as well. A few other things. Fingerprint reader. I don't think that sort of works, but it's all under there. Now, if you want to see also within this what drivers are being used or loaded for your hardware, if you do something like an lspci-v, a lot of this stuff isn't going to have anything like these memory controller target addresses. That sort of stuff you can just kind of gloss over. But if you start scrolling through this, you're going to find, for instance, here's the J-Micron Technologies. That has to do with the host controller for the SD card reader that's built in. You're going to see that it is actually loading SDHCI_PCI for that. You see they're right there. The FireWire controller, for instance, is using FireWire OHCI. These are the important things. R8169 for your Ethernet controller, IWL Wi-Fi for your wireless controller. Sound system is using SND, HDA, Intel. Novu is being used for the video. These are the things that are important to make sure that you build either into your kernel or you set up as a module and load after your kernel is built. So going through here, you're able to find a lot of the most important items for your kernel. Going through, you can just see that each one kind of has that listed there again. USB ports, sound drivers, etc. Now, one thing that I have done, let me see where I'm at here, is you want to go into your user source Linux, and that is actually, if we back up a little bit and look at user source, you'll see I only have the one kernel because I recently built this system, but sometimes you'll have multiple kernels. Linux is actually a link to the source that you're using at this time, in this case Linux 3.10.7. So if we go back into Linux there, I have built a script called build.sh. If we look at build.sh, you'll see that it's pretty much make menu config, and then I use the time option to tell me how long it takes when it compiles for time make, and then time make modules install. Those are the three main command lines that you'll use to build your kernel. After those have completed successfully, all of your modules should be built, made, and installed with the make modules install, and your kernel, if you're 64-bit, will be under arch x86_64/boot/bzimage, or if it's 32-bit, would just be under arch x86 boot bzimage. And what we're doing here is we're copying that then to our boot directory. You can call it anything you want. I like to call it Linux and then the version of the kernel that I'm using, and then what the distro is. So in my case, Linux-3107-Gentoo. I then make a link to that, so it just points to VM Linux, which is a generic line that I use in my grub configuration, so I don't have to remember what version of the kernel I'm using at the time. And also, you don't have to type in so much, and there's less chance for typographical errors. At the end of it, of course, it just echoes that it's been copied, linked, and is good, so that I know it completed and didn't get stuck somewhere else within the process. So the first command, make menu config, is going to create a GUI interface within your window here that allows us to get access to all of the commands and kernel-based configurations. And most of this stuff you don't really need to worry about. And I'll kind of point out and gloss over some of the more important things. For instance, under processor type and features, you're going to want to make sure that you set up what your processor family is. And you've got some options here. Now I'm just using a 64-bit, so I'm just using generic x86-64. But if you had a Core 2 Dual or an Intel Atom P4 older type system, that sort of thing, an Athlon 64, etc., you choose whichever one works best for your system. Another important thing to look at is going into your network support and just making sure that wireless is turned on if you're going to use it. If you have WiMAX, installing that support. The RF switch subsystem, for if you're going to use RF kill commands to manage your wireless. And then this is going to be your biggest area here. That besides your file system area. In device drivers, you're going to find a whole slew of things. Now, if we remember some of that stuff that we are looking for, this is where this can come in handy. For instance, I'm going to go into another tab here. We're going to do lspci-v again, and I am not super user, so let's do that real quick so I don't have to worry about doing sudo all the time. lspci-v. We got all this here. Now, let's take for an example, if we were going to set up, say, IWL Wi-Fi. That's our wireless card. So we go back into here. If you hit the / key, enter the config or substring or something like that. If we look up IWL Wi-Fi, we're going to find places where that is part of the string. And that will give us some ideas of where we might need to go to turn on this. For instance, here in device drivers, we can now see that IWL Wi-Fi is under, and that's right here, this option. That we go into device drivers, network device support, which has to be net devices has to be yes, and then under that we can go into wireless LAN, which is yes, and then it is defined as drivers net wireless IWL Wi-Fi. So we need to remember device drivers, network device support, wireless LAN, and so therefore if we hit the exit, and we go to network device support. We look for wireless LAN, which is right here, and then we look for our Intel wireless Wi-Fi. Now, if you're curious, for instance, as to what this option will give you, you can go to the help right here. Like under Intel wireless Wi-Fi next gen AGN wireless-n blah blah blah. It also has, of course, in parentheses IWL Wi-Fi. Sometimes it's not always nice, but if you go to the help area here, this is going to tell you that it's going to do config_IWL Wi-Fi, and it's going to give you some information about this option enables support for use with the following hardware, and you can check your hardware and make sure that it actually does give the support for the driver system that you need. It also talks about how the driver uses the kernel's MAC 802.11 subsystem, and then talks about down here about the symbol that it's giving and where it's all at, which is what we had looked at before when we had done the / and then checked out IWL Wi-Fi, so we know that we're in the right place. So, like I said, I like to build a lot of my hardware into the kernel and only put as modules things. This is my rule of thumb. If it's built into the system, I build it into the kernel. If it's something I can plug in and take out, then I build it as a module because I don't always want it to be hooked up. Like a FireWire is built, I believe, actually I take that back. My FireWire is built into the kernel. But the SD card, for instance, I have that built as a module because I don't always have an SD card plugged into that slot. If you see an asterisk or a star, that means it's built into the kernel. If you see an M, that means it's made as a module. In this case, we have the IWL Wi-Fi, and I've enabled the DVN firmware support, and I went ahead and put in the experimental peer-to-peer software. And you notice nothing else is checked. That's because I don't want anything else being built for the wireless except for that, because I'm never going to have any other wireless. If I ever wanted to put another wireless card in here, I'd have to come back in here, enable it, and rebuild the kernel. The same thing you can do for your Ethernet driver, except you go to Ethernet driver support, and I know, for instance, it's a Realtek. I got that information from the LSPCI. Now, I don't want the Realtek really built into the kernel because I don't use the Ethernet that often. I mean, I almost never use it. So I've got it set up as a module in this case, so I don't have to worry about it. But you notice everything else is turned off so that I'm not bloating anything or creating unnecessary modules. And those are the only two things within the wireless or network area that you're going to want to worry about. Your wireless card, your wired card, and if you use WiMAX and all that, you'd also look in here, of course, and find your WiMAX card settings and set up the driver for that. If we go and start back at the top, though, I like to just work my way down. Generic driver options, we go in there. Auto mount is in there. Most of this stuff is, if you use the Gen toolkit, and not the Gen toolkit, but the gentoo-sources, it's going to come with most everything basic built proper. If you're ever concerned about building an extra section into your kernel, you're going to want to look for a how-to or an information set up for Gentoo for your specific need. And it's going to tell you exactly where to go in here, turn on what, whether or not it needs to be a module or built in, because some things must be built in, some things must be built as modules, and it'll tell you which ones to do. The thing is, don't be afraid to be in here. And if we look in USB support, for instance, very simple things, it tells you right here, I don't have USB 3.0 on this system, but I've got my USB 2.0 built, and I've got my USB 1.1 down here built. Well, you start to learn things like OHCI is the 1.1, EHCI is 2.2, XHCI is 3.0, and you start to learn those sort of things. If you want to give support for USB mass storage, you turn that on. Otherwise, you'll never be able to plug in an external hard drive. And then there's simple things like USB print support. If you want it, you turn it on. USB modem support, I don't use USB modem, but if you wanted to use it, that's where you'd set that up. If you were using a USB wireless device management, these are things where you'd have to know to turn them on or turn them off. But the biggest thing is if you're looking for information for that, the best thing is to find an how-to article from Gentoo with your specific hardware, and there's always somebody who's created some sort of a configuration to tell you how to do that. All your other things, like here's sound card support, we'll go in that real briefly. We're using the ALSA architecture. I'm not too crazy about Pulse, so I haven't really built Pulse into anything with this particular system, but we go into ALSA, and then here of course is all of your old OSS type support. And then if we go into the PCI sound drivers, you'll notice nothing is checkmarked except for my Intel audio, and then we've got that all set up. And if we back out of that and look at that by hitting the help here, we'll see that this is config for sound HGA Intel. And if you remember on the LSPCI, that's what we had. If we go down here, sound HDA Intel. So I hope I'm not talking too fast. I just don't want this to be too long or too boring. But the big thing, like I said, is not be afraid to look for your driver from a distribution that's loading it. If you know your sound, for instance, is working perfect, look in that LSPCI area, look to see what driver with the -V it's using, and then make sure you come in here, find it, and build it either into it, as like I did here, into the kernel, or making it as a module. Now we back out. I'm not going to go over too much else of this part here because we can go through it again in the building better. Those are the big things though. Sound card, multimedia, graphics. The multimedia, for instance, this is where I set up the USB video class UVC. That's what sets up my webcam that's built into the laptop. That's why I have it built into the kernel. And then I think I've been trying to get my TV camera to work every once in a while, and it doesn't really work. But right now all I have is camera and the USB adapter. If we look at graphics support, you'll see that I'm using direct rendering management, that I have the Novu driver set. I thought about doing just a review about how I set up Novu for Gentoo. If you guys are interested, let me know, and I'll go over that. It's very simple. And then if you need or want the boot logos, you go in here, standard 224 color Linux logos. Like I said, most everything, if you use the gentoo-sources, is there. It's not too difficult to look at. But I want to get out of drivers real quick, because the next biggest thing you want to look at is file systems. Now, within file systems, if you're using RiserFS or ext3, ext4, those sort of things, you want to make sure you build all of this in here, otherwise you will not be able to boot your OS. If, for instance, you had created your boot partition to be an ext2, if it's not set up in here to be able to have that set, running, then it's going to fail. Now, I'm using the extended 4, and they have this excellent option in the newest one that says you use ext4 for ext2, 3, as well as 4. That way I don't have to set up ext3 here or look for the ext2, which is this right here. RiserFS, I always kind of build into it because there's a lot of file systems, a lot of distributions that still use RiserFS. And then I don't use any of these right here, but if you did, you'd turn them on. And then the iNotify, the quota stuff, I leave that all default. I do set up as a module for Fuse. And then down here is really important, your CD-ROM stuff. Making sure that you can read CD-ROMs in the UDF or ISO 9660, all that. Your DOS file support, always make sure that your MS-DOS FS support's there for VFAT. And also, I always use the NTFS file system and write into it, build into it the NTFS write support instead of as a module. Your pseudo file systems are pretty much, I just leave it as it is. Your miscellaneous stuff, I don't use any of this, but if you were to want to set up, say, an Atari or Apple file system, this is where you would go in here. Minix, OS2, a lot of your old stuff that hardly is used anymore, but you might need it. BIOS, you can turn all this stuff on, build it either as a module or build it into the kernel if you use it on a regular basis. Your network file systems, this is important if you're going to have NFS shares. This sets up your NFS client built into it or your server. If you're doing Windows shares, you want to definitely make sure that you've got CIFS support installed. And then, this is just some options that you can put in there for your CIFS. And then I don't use any of the other. Those are the two main ones, NFS and CIFS. Now, CIFS has been replacing Samba. And then your native language support, that's if you want to build in more than just your current language. In my case, it's United States and Canada. But if you were coming from a different country, you would build in for Greece, Turkey, Arabic, Norwegian, etc. All this here, you'd find your local and choose it. And those are the three main sections that you need to worry about. That will recap real quick: your processor type and features, your device drivers, and your file systems. Most everything else should be default, simple things. I've never really had to do anything in security or cryptographic. So after you've made those changes or edited those things, you just go ahead and hit the exit. And if you'd made any changes, it would have said save. Do you want to save these? It's going to save them as a .config file. If we do a ls-lsa in here, we'll see that there should be a .config in here somewhere. There it is, .config, and then I've got my .config old, which is my old one. Always want to make sure when you have a really good working one that you're happy with, copy that somewhere to just anywhere, so that you know that for that version of the kernel, this is a good working configuration. That way, if you do mess up, then you can always put that back in there and rebuild. Now, after you've made your changes, then you just type in make, which we're going to do anyway. You shouldn't make anything because there's nothing to create, but it's going to go through and kind of check things out. And if you had wanted to see if it was going to take a long time to do, you could do the time space make. And then after that, of course, like you saw in my build.sh, make modules install, or it's been a while, /user source Linux build. So like I said, make modules, make modules _install. Go forward, and that's going to build everything for you and put it where it needs to go. So little to do. And then make modules _install. It installs all the modules that I've created, and then as my build script does, you want to copy your BZ image to your boot area and call it what you like. You don't have to create the link the way I do. But that's how you'd create yourself your custom kernel. The big thing is, like I said, using those tools like LSPCI or USB. You get those, of course, by emerge pciutils. I'm pretty sure that's what it's called. See if it'll pop it up here. This has been up to 25 minutes. I can't believe I've been talking that long. See, that's why I was trying to hurry it along, because I can get to really going sometimes. And of course, it doesn't help that it's taking forever to calculate dependencies. But anyway, while that does that, I'd like to say thank you for watching. Give me some ideas of other things you'd like me to do. I am still looking at setting up, and I know every time I talk about this, I just want to make sure I'm doing it right for the Gentoo install. But if you have ideas of things you'd like me to look at, specific ideas, for instance, feel free to let me know. If it's morning, evening, noon, or night, whatever you're having, enjoy it. Thank you for watching. We'll chat with you all later. And there it is. Yep, pciutils is what you'd want to install to be able to get that. And then it would be usbutils for doing ls USB. Thanks for watching, and we'll talk to you later. Bye.